This video is going to show you how to do goals 7 through 10. The first goal, goal 7, asks for you to understand how work impacts the total energy of a system. So if you push a box so it starts sliding, then the box will have gained energy because you're going from a place of rest and it's suddenly moving. So you've applied a force over a distance, which is work, and a work implies or ends up being a change in kinetic energy. This is called what we would call positive work, because your work is acting in the same direction as your motion. Eventually the box slows to a stop. So in this case, the box is going to lose energy because it goes from moving to at rest. This is called negative work. How do you calculate work being done? You're going to need to use the equation work is force times distance. So if a worker pushes a crate across the floor for 20 meters while using a force of 30 newtons, 30 newtons is your force, 20 meters is your distance. You're going to plug those in. 3 times 2 is 6. Add 2 zeros. So 600, and the units for work are joules. We would say this is positive work because you're moving in the same direction as the force is applied. If you were to lift a 20 Newton brick to a height of 30 meters in 3 seconds, calculate the work. So work is force applied over a distance. The force would be 20 newtons. The distance would be 30 meters. The 3 seconds is extra information that's not needed. It's like a distractor in this case. You gotta be careful. Sometimes problems do that. So 2 times 3 is 6. Add your 2 zeros, 600 joules of work. So in this case, you're lifting it up. In this case, you're pushing it forward, and that would be the work done. To calculate power, the power equation is simply work divided by time. Sometimes I might give you a force and a distance and a time and ask you to calculate power from that. So either of these equations would be useful for that. So 24, 2 people of the same mass climb the same flight of stairs. The first person climbs the stairs in 25 seconds. The second person takes 35 seconds. Which person does the most work? All right, since work is force times distance, and in both cases, the mass of the person is the same, and the same mass, and the same flight of stairs. They're going the same height. So same mass. So remember, force could be mass times G, mass times gravity times D. If this is the same, let's say it's 1, G is 10, and the distance is the same for both of them, then the work is going to be the same for both of them. So the work is equal because they are going up the same flight of stairs, the same mass. There's nothing to do with time in the work equation. Notice that? So no time. But when they ask you about power, yes, this does become relevant. Since power is your force times distance over time, the fact that both of them have the same force and distance applied because of the same mass, gravity is the same, distance is the same, but the time is different. So here's the question. If one person takes 25 seconds and another person, let's just put a number in, let's say it's 100 divided by 25 for the first person, but the next guy, 100 is let's say it's the force times distance, but it takes them 35 seconds. Which one is going to give a bigger power? So when you're dividing by a bigger number, if it takes you more time to do it, your number is going to be smaller. 100 divided by 25 is 4, where 100 divided by 35 is 2.8 or 2.9. So the amount of power is less when your time takes you longer to do the task. So which person expends the most power? It would be the person that takes less time. So the first person. When 25 seconds, expends more power, because power is related to time. So this guy right here, the first person, is going to expend more power. And finally, goal 10. Oh, sorry, 2 more questions on goal 9. If you flip over the paper, they ask you, you have 2 light bulbs. One is 20 watts, the other is 10 watts. So watts is the unit of power. I skipped that on the last problem, but so which light bulb will make more light or be brighter? So the more power, the more brightness you're going to have. So it's not going to be the 10 watt bulb. So we have to consider they're not equally bright. The 20 watt charger, or I should say 20 watt bulb, but the 20 watt charger or bulb, because it will make 20 joules of light every second. Or will it because it makes 1 joule of light every 20 seconds? So this becomes kind of a math problem. If you're taking your work divided by your time, they're asking, is it 20 work, which is the joules, over 1 second? Or is it 1 joule over 20 seconds that's going to give you the answer of 20 watts? This one will not, so it has to be the 20 joules over 1. The correct answer would be B. Describe how a 15 watt toaster will be different than a 5 watt toaster. Which will toast your toast faster? Why? So the 15 watt toaster is more powerful because that's what watts measure, is power. So 15 watt toaster is more powerful. And which will toast your bread faster? It's going to toast faster because you're going to, remember, it's related to time. So it's going to take, the more power you have, the less time it will take to do work. So the work, so if you think about the equation, we just did a problem on that on the other page. 15 watts could be 15 joules of work per second. But if you only have a 5 watt toaster, you can only do 5 joules of work per second. So it's going to take you longer if you have a less powerful toaster to toast your bread to the same toast. So which one will toast your bread faster? The 15 watt one. It's going to be faster. 27. A box that weighs 1,000 newtons is lifted a distance of 20 meters straight up by a rope and pulley system. The work is done in 10 seconds. What's the power? So we're going to use, they're giving us newtons and they're giving us meters. So it's going to be most useful to use the power equation that has force and distance in it, because we haven't yet calculated the work. So power equals force times distance over time. So the force is 1,000 times a distance of 20 divided by a time of 10 seconds. So we can cancel some zeros out, 0, 0. So 1,000 times 2 is 2,000 watts would be the power. Extra T there. Would be the power that it gives off. The final 3 problems are similar to that. You're going to calculate the power. So we're going to use the equation either work over time or force times distance over time. So we're going to take, in this case, they give us force, height, and time. So we're going to use the same equation, force times distance over time. So the force is 20 newtons. The distance is 30 meters. The time is 3 seconds. So divide 3 into 30, turns out to be 10. So this would be 20 with a 0, so 200 watts would be our answer here. Problem 29. Brandon lifts a 50 Newton box a distance of 2 meters. It takes him 2 seconds. So you got to be careful. The first question is work. The second question is power. So look at the work equation. Force times distance. So work equals force times distance. The force is 50 newtons. Distance is 2 meters. So that's all you have to do for work. The work would be 100 joules of work. But to calculate power, you're going to take the work done divided by the time. So the work done is 100 joules. The time it took was 2 seconds. So we're going to divide that by 2. So the power would be 50 and the units are watts.